Alright, so in 6.3 they talk about annuities. They talk about the future value of an annuity and the future value of an annuity due. The difference between these two is when the payment is made. An ordinary annuity like this one, the payment is made at the end of the month or week or year, whatever your payment is. This one, annuity due, the payment is made at the beginning. So notice you got this extra parentheses out here that you don't have on the first one. So if you make your payment right off the bat, beginning of the pay period, it's called an annuity due. If you don't, and you pay it at the end, which is more typical, it's called a regular ordinary annuity. Okay, so that's the only difference. So 6.31a gives you the question of find S, and they give you all these, they give you the formula. Okay, and they plug in all the numbers that you already got here. So you know R is 2500 because that's what they give you. You know I is 0.02. You know N is 60. And you crunch everything down. You want to do it very carefully. You want to figure out what this guy to the 60th power is and hit enter. Then subtract 1 and hit enter. And then divide by 0.02 and hit enter. And then finally multiply by 2500 and you get this guy. And so there you go. There's your I, R, N, and there's your answer. Okay, so part B says figure out what the regular payment is if 80,000 is your future value. So you crunch everything down in here and you want to figure out this guy to the 30th power first, enter. Then subtract 1, hit enter. Then divide by 0.04, enter, and now you get this guy. Then divide both sides by that and you get this number here rounded to nearest dollar, which is what they wanted. It's 1426. Number 5, say find the future value of an annuity. Figure out what S is. If your monthly payment is $1,300, your interest rate is 6%, 5 years, compounded annually. So M is 1. M times T is your N, which is 5. Okay? So you plug in everything that you know. And again, you crunch down this guy and subtract 1 and then divide by this. You want to do it in 3 steps. This guy, enter, subtract 1, enter, divide by this, enter, times 1,300, enter. And you get that guy there. So now 7 says find the future value of an annuity. $8,000 paid quarterly. So M is 4 over 3 years at 8%. So remember, N equals M times T. N equals M times T, 3 times 4, so N is 12. So you plug in all the things that you know. Definitely calculate this guy and this guy first. And then figure out this guy to the 12th. And then subtract 1. And then divide by 0.02. And then multiply by 8,000. 8. Same idea. Monthly payment of for 300,000 is paid quarterly. So M is 4. T is 5 years, so M times T is 20, so that's your N. Interest rate is 6, so 0.06 over 4. Remember, I is simply R over M. Interest rate over M, which gives you 0.015. So now you plug in 0.015 in for here, and you plug in 20 there for N. Crunch everything down, you get your answer. Number 9. The Weidmans want $40,000 in 2 years for a down payment on their house. So it's a 2-year for 2 years, and it's $40,000 is the amount you want in the end. So that's your S. R is the unknown. They're making monthly deposits, compounded monthly. So M is 12. N is M times T, or 24. I is interest rate over M, so it's 0.01. You plug in all that stuff and you figure out what this guy is to the 24th. Enter, subtract 1, enter, divide by this, enter, write it down, and then divide both sides by that number and you get 1482.94. Same idea here with number 10. The unknown is the payment. You want 80,000, and they give you 10 years, each 6-month period is compounded semi-annually, so that's twice a year. M times T is 20, so that's your N. I is R over M, which is 0.08 over 2, or 0.04. Now you plug in everything you know, and you get 1.04 to the 20th. Figure that out, then subtract 1, figure that out, divide by 0.04, get that, write it down, and divide both sides by the 29.7 number, and you get your answer. Number 11, here the unknown is time. So 2,500 is deposited at the end of each quarter. Account earning 5%, so it's 5%. After how many quarters will the account contain 80,000? So it's 0.05 over 4, because it's compounded quarterly. M times T is 4 times T. We don't know what time is. So we plug in everything that we know, and notice the unknown there is T. So to solve this, we want to get this thing to an exponent all by itself. We want to get rid of the -1, this guy in the bottom, and this guy up front. We've got to do it in the right order. So we divide both sides by 2,500, and you get this equals this guy. And then you multiply by 0.0125 on both sides, and you only get the numerator now equals this. And you add 1, and you get 1.04 equals this. Now you can use logs. Log base this of 1.4 equals the exponent. Change your base formula here, divide by 4, and you got your answer, 6.771 years. And they want to know how many quarters that is. Well, that's, let's see, what did they ask for? Number 11, they wanted to know, how many quarters. So it's 4 times T, the number of years. So it's 27.08 quarters, or roughly 28 quarters. 12 is the long problem. Number 12 says 4,000 is deposited semi-annually, so compounded twice a year. Interest rate 0.062. They want 120,000 at the end. How long will it take to get $120,000? So you figured out what I is, it's R over M. Figure out what N is, it's M times T. Of course you don't know what T is. Okay, so when you plug everything in, that unknown there is T. So divide both sides by 4,000, and you get this guy equals that. Multiply both sides by 0.013, and you get this guy equals this, the numerator. Add 1. Now you're ready to write this as a log. Log base 1.031 of 1.93 equals 2t. Change your base, figure it out, divide by 2, and that's your number of years right there, 10.7. 14. Says Patty deposits $2,000 at the end of each of 5 years in an IRA. So she does it for 5 years, and it's compounded annually. $2,000, 9% annually. So I is 0.09, N is annual times 5 years, or 5. So you plug in everything you know, and you get this number. So now she leaves the money into an account for another 25 years. Compounded 9%, compounded annually. So it's no longer an annuity, it's just a simple compound interest problem where the answer from the first part becomes the ending amount in the first part becomes the beginning amount in the second part. This is your P. Where over here, for this part, it was S. And now you throw that into another account, and that becomes P now. 1 plus 0.09 raised to the 25th power, and it's over 1 and times 1, so it doesn't change anything there. And you get $103,213. So then part B says, Patty's husband delays doing this IRA for 10 years. Then he makes up for it by putting $2,000 at the end of each year for the next 15 years, compounded annually at 9%. Okay, and so 1 times 10 is 15. 0.09 over 1 is 0.09. You plug in everything you know, and you get this number here. Alright? So then he does that for 15 years. Then he leaves the money in the account for an additional 5 more years. Okay, so for 5 more years he's doing simple interest at t equals 5. M is still 1, compounded annually. 0.09 over 1, there's 0.09. Okay, and so again, this S from the first part, becomes the P for the second part. And you crunch it all down and you get 90,000. So now if you look at how much Patty paid 5 payments of $2,000 or $10,000, and she ended up getting $103,000. The husband paid 15 payments of $2,000, or he paid $30,000, 3 times as much, and he doesn't have as much money. Patty has more money. For one reason, it's because she had an extra 10 years that he didn't have. He started 10 years late. And that amount of time will make a big difference. So now 17 is your first annuity due problem. They actually use the word annuity due. So you use the formula for annuity due, this one. Okay, that one right there. Future value of an annuity due of $10,000 or $2,000, beginning of each 6-month period for 8 years. So T is 8, M is 2 because it's compounded semi-annually. R is 0.06, 6% compounded semi-annually, so 0.06 over 2 is 0.03. Okay, so you've got 1 plus 0.03 or 1.03, 1 plus 0.03 or 1.03 raised to the 2 times 8 or 16 over 0.03. Crunch all that down and you get 41,523.18. Okay, and 18 is the same idea. They're paying $7,200 every quarter, so it's compounded quarterly. They're doing it for 1 year at 8%. So what is the future value of the rent for 1 year? So you plug in 0.02 for I, 4 for N, and this is 1.02 to the 4th minus 1, divided by 0.02 times 1.02 times 7,200, and you get $30,269.09. Okay, 19. How much must be deposited at the beginning of each year? So they're asking what's the payment. In an account that pays 8% compounded annually, so 0.08 over 1 is 0.08. N is compounded annually 1, and T is 5, so N is 5. And they want to come up with 24,000 in the end. So 24,000 equals R, 1 plus 0.08 to the 5th minus 1 over 0.08, 1 plus 0.08. Crunch all that down, times that, and it gets you this guy here. Divide both sides by that, and this is what your R is. 3787.92. Okay, and 24. 24 is an ordinary annuity. Invest $2,000 at the end of each year, so it's compounded annually, and for 10 years. So 12% over 1 is 0.12, N is 10. Plug in everything you know, crunch everything down, and you get $35,097.47. Okay.